Welcome again to our OPAL-RT learning journey. So I am Ismail Kiwi, field application engineer in OPAL-RT Europe, and I'm as well the member of technical support team. And I will be today the responsible of doing this demonstration, the hardware in the loop using an Arduino board. So let's start first with just giving some information regarding the hardware in the loop. So the concept of hardware in the loop is to test the final controller in safer conditions. So for example, if you have your final controller that you want to test, so it is always better not to test it directly with and connect it to the plant because it's dangerous and you don't know if your controller, your final controller, works properly or works correctly. So what you have to do, and this is the purpose of having hardware in the loop, is to connect your real controller to a simulated plant. And this plant will be simulated on an OPAL-RT simulator, for example, or any real-time simulator. And then this simulator will act as the real plant. Like for example, here we can see like a machine or a PV solar, and then you can test your final controller in safer conditions. As well, one of the purposes of having a hardware in the loop is to prepare the final physical tests. And as I told you, no need for the real plant to be available. So you have just to have a simulation, a model of your plant, and then you will simulate your plant in the real-time simulator. And then you can connect it through some physical analogs and digital to your real controller, and then you can test your controller in safer conditions. So just in order to sum up, so the configuration will be that the plant, it means that the physical controller system will be simulated, and the controller will be real, and then by this you will just test your final controller. So here I would like to share with you some application cases. So let's start, for example, with the testing the control of an electrical drive. For example, this is the controller for an electrical drive, and then you send some PWM control signals to the simulator. So here let's, for instance, having a two-level TSB converter that is simulated on the simulator. So let's imagine that all this configuration means that the converter, the LC filter, and the asynchronous machine is simulated on the OPAL simulator, and then you can just communicate with your real controller through some PWM control signals. So here in the OPAL-RT simulator, you will have a PWM in car for acquisition of the PWM control, and then you can call it this converter. And yeah, as I told you, this is simulated on an OPAL-RT simulator and real-time simulator. And then in order to close the loop, you have to send back to the controller. You have to send the measurements. It could be voltage or current measurements, or it could be both of them. So you will send the current measurements and voltage measurements to the real controller, and then by this you will control your converter. So now it's as well, I have another example of hardware in the loop application, and this is a very, very common application that is used in industry. So what you can do is protection relay testing. So you have here your relay testing, and then you send your command in order to open the breakers. Here in this example, I have, this is my network. Here I have the second breaker, and I have here my first breaker. And then here, depending on the value of the voltage and current measurements, I will receive. If there is a fault, it means that I will have, for example, a high value of current, and then the relay will detect that I have a fault, and then he will send the command, a digital command to the breaker in order to open the line. Sometimes it could be this communication. It could be through a communication protocol. Like in OPAL-RT, we are supporting many protocols, and the most common one used in relay testing is, for example, the IPC 61850. So here, for example, if your relay is working with this protocol, this kind of protocol, so you will just send here some boost, and you will receive some sample values. It means sample values, measurements, voltage and current measurements, and then you will have a hardware in loop application. So today, our hardware in the loop application is using Arduino card. It means that this Arduino card will act as a relay, and in this Arduino card, I will have my SIMULINK relay model that will be loaded through USB, and then I will actually show you by the camera how I did all the connection of the configuration. But here I can have my SIMULINK relay model that is loaded through a USB in order to program my Arduino card. And as well, I will have my network model in OPAL-RT, an OPAL-RT simulator. So it will be in HYPERSIM software. So I will have my network model. I will show you this by details after. So I will have on the HYPERSIM software the network that is simulated on the OPAL real-time simulator, and then the real-time simulator will send the current and voltage measurements to my Arduino card through the analog outboard, and then the Arduino card will receive these measurements through analog in. So I have here ports. I will show you that after. I have here some ports on analog in, and I will receive the measurements through my analog in. And then I have my relay model in the Arduino card. And if I remark that I have a very big value of current, it means that I have a fault, then I will send the digital signal to the breaker that are simulated on my OPAL simulator in order to open the line. So this is our configuration today. And we're gonna see by details all the information about the configuration of this hardware unit. So for the Arduino board, as you know, this is a very common board used now in universities and so on. And for me personally, I use this Arduino board in many projects in my university and in my engineering school to do many projects. And as you know, thanks to its simple and accessible user experience, Arduino board has been used in thousands of different projects and applications. And I assume that many of you presenting here in this demonstration, you know about this microcontroller board, maybe better than me. But yes, it is very accessible, very simple, and as well very cheap. And you will find it in many universities and everything companies, because I heard that some companies use this very basic microcontroller to do some basic application. So in addition to that, the Arduino software is easy to use for beginners, yet flexible enough for advanced users. And yes, as you know, it runs on Mac, Windows, and Linux. So this is a very basic microcontroller card. And there is many types of this board in the market. You have the basic one. It's the Uno board, and you can have, depending on the number of digitals and analogs, and depending on the power of the car, you have many types of cars. Here in this demonstration, we are using an Arduino Mega 2560. So for us, it's enough powerful to this kind of application, and in order to connect it with a real-time simulator, in order to do a hardware in the loop application. So this Arduino Mega 2560, it has 45 digital input output pins. So 15 can be used as a PWM outputs, and as well you have 16 analog inputs. So the 16 analog inputs will be used to do the acquisition of the current measurements, and we will send two digital outs our comments with breaker in order to open the line. Okay, so far so good. Okay, so now just for people who doesn't know, just regarding the Arduino programming, Arduino Integrated Development Environment, that we call IDE, is the main text editing program used for Arduino programming. Okay, as you know here, here you can just type some lines of code, and this is very basic, and you have many libraries and many codes that are ready that you can use, and then you can upload to your Arduino card. It is where you will be typing up your code before uploading it to the board you want to program. So it's a very basic code, and you have some command to just to follow. It's like analog read in order like to send some analog signal and so on. Now the question is: it possible to program an Arduino board using MATLAB Simulink? Because this is a very important question. Because if it is possible, it will resolve a lot of problems, and there is people that are familiar with the IDE. I used before the IDE to program, but since now some people or most of people are familiar with MATLAB Simulink, so it was a good thing to think about programming the Arduino card directly through MATLAB Simulink model. Because as you know, in OPAL-RT simulation, we are fully supported MATLAB Simulink. It means that, for example, if you want to run a MATLAB Simulink model in real-time simulator, in real-time simulation, you can just run it without any problem because we are fully integrated and we are fully supported MATLAB Simulink. So here the idea is to think if it is possible to program an Arduino board using MATLAB Simulink. The answer is yes, it is possible, and this is a very good news. MATLAB Simulink, so MathWorks thinks about programming the Arduino card just by using your normal and your normal MATLAB Simulink model, and then you can directly upload it to the Arduino card. And there is a support package for Arduino hardware. It enables you to create and run Simulink models on Arduino board. So the target includes a library of Simulink blocks for configuring and accessing Arduino sensors, actuators, and communication interfaces. So in MATLAB Simulink, I will not integrate this in this demonstration, this presentation, but this is available in the MathWorks website and in many tutorials. Now this is available on how to program an Arduino card with MATLAB Simulink. So there is a support package that contains all the blocks that are needed in order to program your Arduino cards. And you can as well use your normal MATLAB Simulink blocks, for example, your sensors, your scopes, and your displays, and your cascades, and so on. So Simulink block library to connect to the inputs, outputs of the card, and you can have as well direct communication between Simulink and Arduino. Okay, now since we discussed about the Arduino and how to program the Arduino card. Just a quick reminder that we are doing now a hardware in the loop application. It means that my relay model will be programmed in the Arduino, and it will act as a relay that sends some comments to my simulator. And in this simulator, I have my network model that is simulated, and then I will send back the current result. So now, since everything is okay regarding the Arduino card, now let's move to my HYPERSIM model. It means that the network model that is simulated in my OPAL-RT simulator. So this is a network. It contains here some transformer and so on, generator and so on. But the most important thing that here is that here I have a fault happen. So this block allows me to apply a fault. It could be a one phase to ground, or two phase to ground, or three phase to ground. It depends on my application. And the second thing is that here I have my current measurements that I have to send to the Arduino card in order to, if it is very high, it means that there is a fault, and then my Arduino will send the current to here to open the breaker. So this is my current measurement that I will send to my Arduino card. The third, here the important block is the on-off signal receive. Which means here I will receive all the signal that comes from the Arduino card. So this is the common of the Arduino card, common relay. And here the fourth block is the breaker operates. It means that when I will receive my digital signals coming from the Arduino card, here I will send the command to these two breakers in order to open this line. So here, yes, this is just return back to the relay model. So the relay model that is run, that is uploaded in the Arduino. So this is my MATLAB SIMULINK model. So it's not, I will not work with the IDE programming line called Arduino, but I will just upload the MATLAB SIMULINK model. So here inside my Arduino model, here I have my three analog inputs. The first one, the second one, and the third one. So this is the current measurements coming from OPAL-RT simulator. So here I have my current measurements that comes from my OPAL-RT simulator. Then here I have my relay model. I will show you in details what is inside this block. And then here I will send my command. So I will send my digital output. So this is the control signals to be sent to the simulator. Okay, now let's move to the demo time. So here I will just open first in order to show you. This is the Arduino model. So here it is running. I just have to put here my analog inputs, and here the analog other inputs. So this is my model of the Arduino card, and here this is my OPAL-RT simulator. So I will show you after the back of the simulator where is connected to the Arduino card. But this is my OPAL simulator. So here I have here some SFP modules. Here I can as well connect with the central. This is for other applications. So this is my OPAL OP4510 simulator. It's very powerful, and we can use many applications with this simulator. So here in the simulator, I will simulate my plant. It means that I will simulate my network, and inside the simulator, I have here on the mezzanine, I have some digital and analog cards, and then using these cards, I can communicate with the real controller. So this is my OPAL-RT simulator, and then I will communicate with my Arduino card. So I will just now show you what is inside this simulator. So this is my HYPERSIM. This is the software HYPERSIM. So inside I have my model. So this is my network model. So as I told you here, I will receive the digitals that comes from the Arduino card. Here I have my breakers. This is the second breakers. Here I have my current measurements, and then I will send these current measurements to Arduino card. And here I have the fault. So here I can apply a fault. It means here I will start the fault at second 0, 1, at t equal 0, 1, and I will stop the fault at t equal to 0, 2. Okay, and here I can, for example, choose which fault I want. For example, here I want fault A to ground and fault A to ground, and I want to apply a fault of 0, 1 seconds. So we can do that. So this is regarding my network, my network HYPERSIM in OPAL-RT simulator. Okay, so that's it. Now let's move to the Arduino model. So this is my Arduino model. Here I have my analog inputs. So here, if I double click here, I can choose here the pin number and the sample time. And here I have to choose. So this is for the phase A, the phase B, and the phase C. Here inside I have some, in order to convert the units between the Arduino analog counter, because it is written with the 0 and 5 volt, and the analog counter max value is from 0 to 1023. So I need this block to do the conversion. So here I will receive an analog engineer value. It means that my maximum value of the current will be 10,000, because my nominal current value is 2,000. So the max value is 10,000. So this is why I put here the max engineering value and the max analog voltage and this value. Here inside my relay, I will have here, I will compare the value of the current with this value. I will explain actually why I choose this value, but here I will compare with this value. It means that if it is bigger than 3,800, so then I will send a trigger to OPAL-RT in order to open the breaker. And then here I will send my signal, my digital signals to my OPAL-RT through this block, so digital outputs. And then here I can choose the pins that I want to connect. Okay, so this is the configuration. So here I will show you this is my OPAL-RT simulator. So here. Here I will show you in the back of the simulator. So this is my my analog card, and this is my Arduino card that is connected to the simulator. And then through this this blue cable, I will apply the relay model to my Arduino card. So this is the connection here in the back of the simulator. So here I have my analog output, and here I have my digital input. Okay, so now let's see the simulation. So here I am simulating my simulation. So what I will do is I will open the scope view here that shows me this is the the breaker state. It means here that if I go to my HYPERSIM model, if I apply here, let's for instance, here I have an phase A to ground fault. Here I want to apply the fault at 0, 1, and I want to stop it at 0, 2 seconds. It means that it will start at 0, 1 and then it will last 0.1 seconds. So here let's see what will happen if I here open to see this is the state of the breaker. So if you see here at 0.1, I have that the breaker, the command, it means that I received the order from the Arduino card that I want now to open my breaker, because I choose here this demonstration to if I have a fault in phase A to ground, my choice is to open the 3 phases. It could be, for example, if you have a fault in A, you want just to open the breaker of the, you want just to open the phase A. But here I choose, if I have a fault in one phase, or for example, phase A, I want to open the breaker and I want to open the 3 phases. So here, if I zoom, if I choose this graph, here I see that when I have here a big value of the current, because the value of the current I receive them in the Arduino card, and if you remember here, I have my relay test, so I received all the values of analog inputs here, and then I will say, oh, if it is greater, it is bigger than this value, or if it is smaller than minus 3080, so I have to send through this digitals, I have to send the command in order to open. So here, since I have a very big value that exceeds the relay value, so I receive the order from the Arduino card that I have to open this line. So this is why I opened here during 0, 1 seconds the three phases. What we can do as well is we can go and just try to put here another fault like phase B to ground, and then if we apply, and we will see that here the phase A it's in the red color, the phase B is in blue color, and the phase C is in green color. So if I just now take an acquisition, so this is the current in my line. So if I just click here, so I will see here that the current of my phase B, since I have a fault here in this phase, so I have that it will increase, and since the Arduino card will detect that this is a very big value, then the Arduino card will send the command in order to open the breaker. So this is the case, and then here I can do a recovery, and then I can close the breaker, and then I can have a recovery. So I don't know if you remark here, I have a small delay comparing to the phase A here, because the phase B is not going to very high levels, and since the time step of my OPAL-RT simulator model, it means that the network model is 50 microseconds, and the time step of my Arduino card is 1 millisecond, so it's 5 milliseconds, sorry. And so it takes some time in order to respond, and here I have some delay, but it is a very good result for a very basic card, honestly. So here I have here's some delay, but yeah, it will I will receive the order in order to open the 3 phases, and here I will have the recovery of the voltage. So let's try again. For example, in order, if I want to put a phase C to ground fault, I want to choose at 0, 1 seconds of a duration of 0, 1 second. So I will just apply, and if you remember, uh, the 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 fancy, it's in the green color. So let's do an acquisition, and here, yes, I have some delay, and I can do many acquisitions. So here you see that I have here an increasing of the value, and then when the Arduino card detects there is a very big value, then then I will then Arduino card will send the command to open the breakers. Here I can do many acquisitions in order to be sure that I have a good results, and by this I am sure that I have a good result. Okay, so here this is all I have to say regarding this Arduino demonstration. So here I have just one other remark before finishing, is that um, you may ask a question why I put this value instead of like putting instead of fixing the value of around 2000 ampere of the current, because as you see here, the nominal value of the current is around 2000. So the question is why I don't put a value of around 2000. So because what happens when I have a recovery is that when I have a recovery, the value of the current will increase again. And when it increases again, and if I choose the if I choose a small value of detecting the fault, what will happen is that I will detect another fault. But in reality, there is no fault. This is just the recovery of the current. So this is why I put a value that is enough big in order when I have the recovery, I will not detect the fault again. So it is all for this demonstration. Thank you for following my presentation, and for yeah, being here, for participating to this demonstration. I hope I was clear, and yeah, for sure, all your questions are welcome. All your questions are welcome, and I will be more than glad to answer all your questions. Thank you so much.